This is Karthik, studying in Sri Venkateswara College of Engineering, CSEI student. So today our topic is support vector machines. So what is meant by support vector machine? So after completion of this video, you will be able to understand how does it work, what are the support vector machine parameters, and what are the advantages and disadvantages of support vector machines, and why do we use and in which fields we use this support vector machines, and what are the variants in that, and the conclusion. So you will get good knowledge about support vector machine after completion of this video. So introduction to SVM. It's a powerful machine learning algorithm used for both classification and regression tasks. So it is a powerful machine learning algorithm. It is basically an algorithm and it used for both classification and regression tasks. It is mostly used in classification problems such as text classification, image classification, and bioinformatics. It is mainly used in classification problems such as text classification, image classification, and bioinformatics. In the support vector machine algorithm, we plot each data item as a point in n-dimensional space. With the value of each feature being the value of particular coordinate. So this is how we represent the support vector machine in xy coordinates. Then we perform classification by finding the optimal hyperplane that differentiates the two classes very well. Then after that, after plotting them, so we perform classification by finding the optimal hyperplane that differentiates the two classes very well. So this is the introduction about support vector machine, and we will see the how does it work, how does support vector machine work. Support vector machine is a binary classifier that separates the data into two classes by finding a hyperplane that maximizes the margin between two classes. It mainly divides the data uh, into two classes. The margin is distance between the hyperplane and the closest data points from the each class. What is the margin? Margin is the distance between the hyperplane and the closest data points from each class. Support vector machine can also handle non-linearly separable data by transforming the data into a higher dimensional space. Identify the right hyperplane. Here we have three hyperplanes A, B, C. Now we identify the right hyperplane to classify stars and circles. Select the hyperplane which segregates the two classes better. In this scenario, hyperplane B has excellently performed the job. So in the image there are three hyperplanes A, B, C. We need to separate the stars and the points. So which one is doing well? So B is performing well. So you can go through the image. So after going through the image, you'll get clarity that B is better in this case. So and the next one is how does it work? Identify the right hyperplane. Here we have three hyperplane. This is already completed. Here the maximizing the distances between the nearest data point and the hyperplane will help us to divide the right hyperplane. The distance is called margin. So understood this. Here you can see that the margin for hyperplane C is high as compared to both AB. Here we name the right hyperplane as C. Another lightning reason for selecting the hyperplane with a higher margin is robustness. If we select a hyperplane having a low margin, then there is a high chance of misclassification. This is how support vector machines work. And what are the parameters of support vector machine? C is a regularization parameter that controls the trade-off between maximization, the margin, and the minimizing the classification error. Gamma is the parameter that controls the shape of the decision boundary. High gamma values lead to more complex decision boundaries. Kernel function is a function that transforms the input data into higher dimensional space. Common kernel functions include linear, polynomial, and radial basis functions. These are the three parameters of a support vector machine. First one is C, and second one is gamma, and third one is kernel function. And advantages and disadvantages of support vector machines. First we will go through the advantages. SVM can handle high dimensional data and large data sets efficiently. SVMs are very efficient in handling high dimensional data and large data sets. SVM is robust to overlifting due to its ability to control the complexity of the decision boundary. Support vector machine can handle non-linearly separable data by using kernel functions. These are the main advantages of support vector machines, and we will go through the disadvantages of support vector machine. The first disadvantage of support vector machine is sensitive to choice of kernel function and its parameters. This is the main disadvantage of support vector machine. And support vector machine can be computationally expensive for large datasets and complex kernel functions. It is computationally expensive for large datasets and complex kernel functions. Support vector machine does not provide probabilistic outputs, which may be necessary for certain applications. It does not provide probabilistic outputs. So those probabilistic outputs may be useful for certain applications, but this support vector machine does not provide that. So this is the one of the disadvantage of support vector machine. And applications of support vector machines. Why do we use this support vector machine, and what are the in which fields we use this support vector machines? Image classification. In image classification we use this support vector machine. And text classification. In text classifications, support vector machines is used. Support vector machines has been used to classify text documents into different categories such as spam filtering and sentiment analysis. So this is why we use the support vector machine in text classification. And the third application of a support vector machine is bioinformatics. Support vector machine has been used to classify genes based on their expression patterns or to predict protein interactions. So in bioinformatics we use vector machine, and support vector machine has been used to classify genes based on their expression patterns or to predict protein interactions. So this is why you use support vector machine in bioinformatics. Variants of support vector machines. One class support vector machines. Types of support vector machine. There are three types of support vector machines. The first one is one class support vector machine. Use it for anomaly detection by finding a hyperplane that encloses a single class of data points. This is one variant of support vector machine. And the second variant of support vector machine is support vector regression. This is also called as SVR in short. Use it for regression tests by finding a hyperplane that minimizes the distance between the predicted values and the actual values. This is the second type of support vector machine, second variant of support vector machine. And third one is multi-class support vector machine. Use it for multi-class classification by constructing multiple hyperplanes to separate the different classes. And this is the third variant in support vector machines. You got to know these are the three variants of support vector machine, right? So we'll go to the next. Conclusion. Support vector machine is a powerful machine learning algorithm that can handle high dimensional data and large data sets efficiently. Support vector machine can handle non-linearly separable data by using kernel functions. Support vector machine has a variety of applications in fields such as image classification, text classification, and bioinformatics. This is the conclusion about support vector machine. I hope you understood and you got some good knowledge about this support vector machine. If you like my video, please like, share, and subscribe my channel. Thank you.